Hello everyone, you are welcome to this video. I remain your tutor, Mr. Life Changer. Here I'm going to continue from the part 1 of the MCQs as involved electrolysis. Okay, so here we are looking at, we have number 12 here. It says, according to the ionic theory of electrolysis, cations in an electrolyte migrate towards the cathode because it is negatively charged. Yeah, I already explained that in the first video. Anions always migrate to the anode, cations always migrate to the cathode. Okay, and I already mentioned that anode is positively charged. That is why anions move there. Anions are negative. Cathode is negatively charged. That's why cations move there. Okay, now the next question says, in the electrolysis of copper 2 sulfate solution, the copper ions are discharged at the cathode by the process of at the cathode. Reduction always happens at the cathode, like I mentioned. So the answer is reduction. Oxidation always happens at the anode. Reduction always happens at the cathode. Please note this, very important. Now the next question here says, okay, here we are dealing with mechanism of electrolysis. This one says, during the electrolysis of molten lead 2 bromide, lead is deposited at the cathode. The half equation is, now before I continue with this, I like to explain the mechanism of electrolysis. There are three major areas of electrolysis. The first one has to do with separation or migration. And I think I've dealt with migration. Cations always move to the cathode and anions always move to the anode. Okay, then after migration, the next thing that happens is what we call discharge. So discharge, an ion is discharged when it loses or gains electrons. These are exam questions, so please take them seriously. An ion is discharged when a cation moves to the cathode. It is discharged. When an anion moves to the anode, it is discharged. To be discharged simply means to either lose or to gain electrons. Okay, so a cation is discharged by gaining electrons. Listen, a cation is discharged by gaining electrons, but an anion is discharged by losing electrons. So if the cation is, let's say, copper ion, for example, it has to gain electrons to become copper atom, and the charge balances to become copper atom. But if it is chlorine ion that is discharged, it will discharge by losing electron and producing chlorine gas. So this will lose electron, this will gain electron. That's the difference. A cation is discharged by gaining, an anion is discharged by losing. That's the reason why the answer to this question is A, because it says, during electrolysis of molten lead bromide, lead is deposited at the cathode. The half equation of the process is, at the cathode, this is what happens. Electrons are gained. They are discharged by gaining. The ion gains electron and becomes a metal. Metal is deposited. Very, 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 very important. And you should not forget the end product of electrolysis, which is the third mechanism, process in the mechanism, is that there will be production. That means the purpose of electrolysis is the production of gases or metals. I've already mentioned this before, that at the anode, gases are usually produced at the anode, and at the cathode, what is usually produced are metals. The only gas that can be produced at the cathode is hydrogen gas, because hydrogen is the only substance that is electropositive but a gas, right? So apart from hydrogen gas, which most time is produced during electrolysis, what we always have is metals produced, and that happens when the metallic ion gains electron. Gaining electron makes you neutral. If you notice, +2 - 2 is 0, makes you neutral. That's why you have here. Okay, that is the last stage of electrolysis. So the first stage is migration. Anions migrate to the anode, cations migrate to the cathode. The second stage is discharge. Discharge happens when an ion gains or loses electrons. Cations are discharged by gaining electrons. Anions are discharged by losing electrons. Then the third stage, after discharge, gases or metals are produced. Okay, so that's why we cannot say this, because this is not a metal, this is an ion. It cannot be B. Let's see the other options. You can see bromine is an anion. Bromine can never be discharged at the cathode. Bromine here is not possible to be discharged at the cathode, because cathode is only for anions. I mean for cations, while anode for anions. I hope this makes sense. Okay, so I want to also note something, that after electrolysis some things will remain. The electrolyte will turn either acidic, or will turn more alkaline, or will be more concentrated, or will be more diluted. Whatever it is, I'm going to discuss that as we continue. Now the next question here says, in the electrolysis of brine concentrated sodium chloride using inert electrodes, the product at the cathode is, now I want to say this, cathode, remember it has to be a positive ion that will be discharged at the cathode. So the answer to this question is hydrogen gas. Now I want to say something here, just for you to remember. This makes it easy. At the cathode, right? At the cathode, it is always hydrogen that is produced. So I'm going to write here that hydrogen gas is usually produced. Now, but not always. Usually means that there are exceptions. Now, and there are only two exceptions. Except if the metal is below it in the electrochemical series. That's except if the metal it is competing with is below it in the electrochemical series, because there's always a competition. I will explain that. Like maybe you have copper, is a salt of copper, a salt of silver, a salt of gold. Copper, silver, and gold are metals that are lower than hydrogen in the electrochemical series. If this was concentrated copper chloride, concentrated silver chloride, or gold chloride, then I cannot say hydrogen. I know it is either copper, silver, or gold. That you should know for exam purposes. Remember, this video is for exam purposes, to make things easy for you. Hydrogen gas is always produced at the cathode, but except if the metal ion involved is lower than hydrogen in the electrochemical series, and they are not much. You can see we have copper, we have silver, and we have gold. I hope this makes sense. Now, but in the case of another exception, this is exception number 1, then we have another exception. I can call this exception number 2. There is a time where sodium can be discharged. Sodium is discharged when the cathode is mercury. The only time sodium is discharged is when the cathode is mercury. So because sodium is very attracted to mercury, sodium will combine with mercury to give us what we call sodium amalgam. We call this sodium amalgam. Now, but this does not work here. We have sodium here, but the problem is that we are using inert electrodes. Inert electrodes is either platinum or graphite. Graphite is a type of carbon, so we can also say carbon. Okay, and that are inert electrodes. So assuming the cathode was mercury, sodium will be discharged, because sodium is very attracted to mercury. But at the cathode, hydrogen gas is always the priority, except the metallic ion is lower than it in the electrochemical series. Then if it is sodium, then it means that the cathode will have to be mercury. Anytime an ion has a very strong attraction to the electrode, that ion will rather be discharged and would produce its consequent metal. I hope you understand this. Okay. Now, but in the case of anions, in the case of anode, I already mentioned that at the anode, always expect oxygen. Oxygen is always discharged at the anode, or will I say oxygen is always produced. At the anode, OH is discharged. It is OH ion that is discharged. OH ion comes from water. OH ion is discharged, but oxygen gas is produced. Anytime OH is discharged, oxygen gas will be produced. And in the last video, I already gave you guys the formula is always written like this. 4OH will give us H2O plus oxygen, then plus 4 electrons. This is the equation for the discharge of ions in the anode. For the discharge of hydroxide ion in the anode, you see that oxygen is produced, but OH is discharged by losing electron because it is an anion. I hope you understand this. If you have been reading this, what I just explained now is going to help you very much, but you can always reach out to me for more explanation. Okay, so the next one has to do with preferential discharge or position in the electrochemical series. Now, before I continue here, I want to say this. If an electrolyte is a solution means that the substance is dissolved in water. 4 ions are always produced or are always involved. If I take a solution of sodium chloride, for example, I'm going to have sodium ion, I'm going to have chloride ion, right? But because it is dissolved in water, I'm going to have hydrogen ion and I'm going to have OH ion, which makes up water. Now, the sodium ion and the hydrogen ion makes up what we call, both of them compete for the cathode. Okay? And while the chloride ion and the OH ion, both of them compete for the anode. So if they ask you which one migrates, you say sodium ion, hydrogen ion migrates to the cathode, and while chloride ion, OH ion, both of them migrate to the anode. I want you to understand that is what you should know about migration. Now, but after migration, the two of them will not be discharged. Only one will be discharged. And there are conditions to know the one that will be discharged. One of them is the position of ion in the electrochemical series. That is why I said that for most metals, hydrogen is discharged, because if you look at the electrochemical series, hydrogen is below most metals. The electrochemical series, I don't have to do that here, but you have, these are what is involved in the electrochemical series. I think we have magnesium, we have zinc, okay, no, there's aluminum here, we have zinc, we have iron, we have tin, we have lead. Then before you have hydrogen, you can see that most ions are above hydrogen. Then below hydrogen, you have things like you have copper, you have silver, and you have gold. You have mercury somewhere here too. Okay, and that is very, very important. So in most cases, because hydrogen ion is lower, hydrogen will be discharged. That's why I said hydrogen is always produced at the cathode. Okay, now except, I gave exception, except these ones that are lower than it in the electrochemical series: copper, silver, gold. If there is copper, there is silver, there is gold, then know that they are the ones that will be discharged, because they are lower than hydrogen in the electrochemical series. Please note this. So there are 3 factors that affect preferential discharge. One of them is the position of that ion in the electrochemical series, which is just what I explained. The second of them is concentration of the ion. I explained that using chlorine. I said that chlorine, if chlorine is concentrated, oxygen will not be produced. What will be produced is chlorine that will be produced. If chlorine is concentrated, like concentrated sodium chloride. Okay, so chloride ion will be like, in this case now, between Cl and OH, OH will always be produced because OH is lower than chloride. But if the solution is concentrated, then chlorine will definitely take the upper hand. And this is specifically for chlorine, and there is a reason for that, okay, which I cannot go ahead and explain in this video, but just know this for exam purposes. Now, number 16 says, in the electrolysis of a solution containing both copper ion and zinc ion using inert electrodes, which ion is preferentially discharged at the cathode? In an electrolysis of a solution containing both copper ion and zinc ion, of course copper will be discharged because copper is lower than zinc in the electrochemical series, definitely. Now the next one says, during the electrolysis of dilute H2SO4 using platinum electrodes, okay, OH ions are preferentially discharged at the anode rather than SO4 ions, because I already explained that, because OH ions are lower in the electrochemical series, they are easier to discharge than SO4. So the answer to this question is B. Like I said, OH ion is always discharged, except I think in OH ion you have something like this. You have OH ion, you have iodine, you have bromine, you have chlorine, then you have NO3, then you have SO4. This is the order. OH is the least of them, easily discharged, okay, except when chlorine is concentrated. Don't forget that. Now, effect of concentration, I think I already explained this. When concentrated hydrochloric acid is electrolyzed using inert electrode, the gas produced at the anode is chlorine. It would have been oxygen, but remember, chloride is concentrated, so chlorine will be discharged. Very easy. Number 19, if the concentration of sodium chloride in brine is reduced to a very dilute solution, an electrolysis is carried out. Remember, it is reduced to a very dilute. It is now dilute. The gas produced at the anode changes from chlorine to oxygen. You see that? If it was concentrated, chlorine will be produced. But now that it is dilute, oxygen will be produced. The best illustrates this effect. A. Nature of electrode on preferential discharge. No. B. Temperature on the rate of electrolysis. No. C. Concentration on the preferential discharge of ions. That's it. That's the answer. That is why that happens. Then number 20, which is where I'm going to end in this video. In the electrolysis of copper 2 sulfate solution using copper electrodes. Now, I told you that there are 3 factors that affect preferential discharge. We only discussed 2, which is the position of ion in the electrochemical series and the concentration of ions. We did not discuss electrodes. Now, for electrodes, there are 3 points you should note. The first one is that in electrolysis, generally, we use inert electrode. Inert is I-N-E-R-T, inert electrodes, and there are 2 of them. We have platinum and graphite. Graphite, also called carbon, is a type of carbon, an allotrope of carbon, okay? And I want to only say one thing here. Anytime you're expecting oxygen gas at the anode, don't use carbon, and use platinum, don't use carbon. And anytime you're expecting chlorine gas at the anode, don't use platinum. The reason is because oxygen attacks carbon and chlorine attacks platinum. So when you're expecting chlorine, don't use platinum, use carbon. When you're expecting oxygen, don't use carbon, use platinum. That's what I can tell you in the first one. Now, in the second case is that there are some ions, even though they are not supposed to be discharged, but if you use certain electrodes, it will make them to be discharged. And I gave you an example, but this was in the part 1 of this video, that sodium, for example, sodium can never be discharged in any case, except when you use a mercury cathode. Because sodium is very attracted to mercury, very, very attracted to mercury, sodium is discharged instead of mercury. Sodium is discharged instead of hydrogen. Normally it's supposed to be hydrogen, but in this case sodium will be discharged because it is attracted to mercury. So when the cathode is mercury, sodium will definitely be discharged. I hope this makes sense. Now, but there is a case 3. This one is a special case. This one, the solution is a solution of a salt of a metal that is lower than hydrogen in the electrochemical series. That means like copper sulfate, like silver nitrate, like gold nitrate. So it must a solution of a metal that is lower than hydrogen. In this case, 2 conditions. First of all, the solution must be a salt of any of those metals that is lower than hydrogen in the electrochemical series. Then secondly, the anode must be that metal. The anode must be that metal. So what this means is that if I have, I don't have enough space here. What it means is if I have, let's say, if the solution is copper sulfate, then the anode should be like copper. This is solution, this is anode. If the solution is like silver nitrate, the anode should be silver. If the solution is gold nitrate, the anode should be gold. You see, That's the condition for this case 3. And what you will notice, once you have this set up, what you will notice is that, and you start the electrolysis process, the anode will dissolve. The anode will dissolve into the solution, then go to the cathode and accumulate. That's why this is what we use in electroplating. That's why electrolysis is also used in electroplating, because the anode will dissolve into the solution and go to the cathode and accumulate. This is what happened. This is the equation. The anode, for example, copper, if I'm using copper, cathode, copper will dissolve, that's at the anode. Then when it gets to the cathode, the ions will gain electrons back and be deposited as copper. So that's why we use this for electroplating, and we also use it for for purification of metals. The impure metal will become the anode, and so when it dissolves, the impurities fall on the ground, and the pure one goes to accumulate on the cathode. That's the simple process here. Okay, so let's look at this, and here we are dealing with nature of electron. Number 20 says, in the electrolysis of copper 2 sulfate solution using copper electrodes as opposed platinum electrodes, remember, the concentration of the solution remains unchanged because A says no current flows through the solution. No. B says the copper ion anode dissolves, replenishing copper ions lost at the cathode. You see that? So it replenishes. The process is a cycle, just like I told you. You can see two different sides of the same equation, and that is the answer to the question. C says copper is deposited at both electrodes. That's not true. D says SO4 ions are discharged at the anode. That's also not true. Okay, so I am going to stop here at this point for this video. I'm taking a lot of sacrifice because I am seeing that a lot of students are appreciating what I'm doing, especially those writing exams. So I put myself under pressure to bring out this video. Okay, so I'm going to stop here and continue in the third video, which may come much later in the night. Okay, thank you very much. And those of you writing JAMB exams today, I wish you the best. Thank you.